I'm back on time. The next presentation on the Learned Society Talks is by Professor Alan K.T. Lau, Vice President, International Vice President, IMEC. Can I invite Professor Alan to take the podium?
Thank you. Just to make sure. Hi, good morning. Firstly, I will try to finish my presentation within 15 minutes, but because originally when the organizer told me about to do the presentation, I just take out one I did for 45 minutes. And but just today, yesterday, I just knew I only 15 minutes try to have to finish the whole things. So this morning I try to cut down some slides and hopefully I can finish it. One thing is the reason you asked me about why I picked these topics. That's a very important thing. When we look at the Asian Pacific regions, we know about there's a lot of new development in engineering disciplines. But one of the disciplines growing very fast is in aviation, particularly in Asian Pacific region and China. And even now you're talking about Japan, they also try to build their own aircraft as well. So that's the reason I try to make the topic is more close to our recent developments. And that's the reason why I picked a new challenge for the IMEC towards the aviation industry. And my background basically on the aerospace engineering, and also I worked in the aircraft design for 4 years in the past. So before we start to talk about aviation, then we have to understand about its history. But when you talk about aviation, a lot of people will think about that as aircraft. But in terms, aviation is much more than aircraft. If you look at the history, we start from the small, like the steam device, okay, and then go to the glider, and also some of the people a lot of curiosity trying to make himself like a bird. And later on, we have an engine developed, then we have the first aircraft. Of course, in all the books, talking about Wright brother is the first one to build and design an aircraft, but that is only in the record. But in reality, long before the Wright brother, that's already have some aircraft already flying on the sky. But then go to aviation. What is aviation? My emphasis is here is I want to tell the people aviation is not just aircraft. Think about today, okay? If some of the delegates here, you are coming from overseas. Start from today, start from the main entry of the hotel. On the way, you go back to your country. Everything happens in the journey that's related to aviation. What does that mean? You get a taxi. The taxi is the taxi from here to the airport. You go to the airport, you check in. There's a lot of people helping you to check your passport. And then when you get into the immigration, there's a lot of people checking your stuff. And then when you get in the immigration, you get hungry and go to eat. And then after you get in the airplane. And could design the aircraft, could make the flight planning quite convenient for the passengers. All of the job natures within this area are related to aviation. So when the time we talk about if you want to build one way, actually the one way will be beneficial to so many industry, and all this industry actually contribute to the aviation. And if you look at here, aviation industry basically is comprised of the aircraft manufacturing and supply of the products and also the components. And airline industry is the other ones under the aviation, and also airport industry. So if we talk about we want to change the professional to serve in the aviation industry, we are not talking about pure engineers. But when you look at the statistics, in the past, Asian Pacific region is not contribute much in the aviation industry, but we have a predictions in 2030. All the predictions by Boeing, by all the aviation organizations, and even Airbus, the precision normally is go to 2030 or 2032. And you will see at that time, by that time, Asian Pacific already dominates the whole aviation market. And the growth is very, very fast. And you can see what happened is that India growing very fast, China is growing very fast, Sri Lanka here is growing very fast. So a lot of people, they just get their planes, come to these areas to have a investment, meetings, or during their business. But because of this, how many new aircraft will be come up in the next 10 to 15 years? According to the projections from Boeing, it's go up to 40,000. And even talking about Airbus is very similar, 30,000. So what happened about aircraft in new aircraft? One new aircraft, we need 10 pilots. 10 professional engineers and still have 30 technicians. So all of them are related to engineering. And then I still did not count those people do the maintenance of the airport. And if you go to the airport, you will see there's a lot of mechanical engineer there, but their work is to do the maintenance of the whole airport, the system, their components, their infrastructures. But if there's so many aircraft, then what is another problem? Pollution. Pollution is one of the key factors driving the aircraft producers or manufacturers to design a new type of aircraft. Because now if you look at the information here, about 2% of the greenhouse gas is produced by the aircraft. And another problem is even talking about the greenhouse gas, that's one of the problems. Another problem is fuel price. So if you look at the information here, actually this information from the chief pilot of our Airbus, I asked him about this. I asked him about how much if you want to fly from Hong Kong to Los Angeles, what is the price for the fuel? And he told me it costs about 100,000 US dollar. So that means the plane is empty. Then we still have to pay, the airline still have to pay this 10,000 US dollar for the fuel. So this is also another main drive to force the aircraft producer to design the aircraft which is more environmentally friendly. But what happened in this curve? If we're not doing anything, then of course the carbon emission will go into this point. So now there's a lot of actions related to engineering to see how we can reduce the carbon emission down to this level. So we have a lot of way to do. Okay, design the flight path that is more environmentally friendly, using a new aircraft, design a new engine using the environmentally friendly fuel. Of course, when you're going back to the legends, all these are environmentally friendly. If you talk about flying object, go to the there's a long time ago, okay, we talk about the magic carpet. There's no fuel at all. There's no carbon emissions. And go to the fish, okay, he's also used the magic power to fly. And later on, people think about, okay, using the bird. For these two, only for the imaginations. From now here, it's come to the human curiosity. Start to think about why the birds can fly, and then whether we can fly by using the birds. And go to this one, is one of very famous legends. And I remember this legend actually is the first page in all aerodynamics handbooks or textbooks. What happened is that one day the son is committed a crime, and then he have to go to the jail. And his father every day bring him one feather. And then until several years, the son already got sufficient feather and used the wax to stick all the feather and make the ring. And then he's trying to climb over the castle, the high wall, and then to escape from the jail. But the problem is that when the time he's flying over the top of the jail, then because that day is very hot and it's a very sunny day, and when the time is flying in a high altitude, that's very close to the sun, and the temperatures increase and getting the wax to melt, and ultimately he could not be able to escape because all the wax melts, and then all the feathers separate, okay, into different places, and then he's dropped back into jail. So a lot of people will think about this is very important because this is the first person to fly on the sky. But in reality, if you are engineers, you know about when you go into high altitudes, the temperature is decreasing. When the time you're flying, the outside temperature is about minus 56 degrees Celsius. So these legends tell the people about don't trust this legend. And you have to use your engineering mindset, your engineering knowledge to judge whether this is true or not. And of course, always there are people using this one as their first lectures to tell the people what is atmospheric conditions. When you have to understand it before you design the aircraft. So to be an engineer, the same. You have to understand a lot of fundamental knowledge before you go further to design your engineering structures. Otherwise, the disaster will come in the future. So later on, the people know about the physics. Okay, they know about if you have something, the air is lighted, the gas lighted the air, then you can lift up your object. And come to now, the green aviations. Because that's the previous slide just telling you about how we can make our flying object green. But now it's really we already have flying objects, then we have to make it green. And this is a new challenge to all the engineers. I'm sure that mechanical engineers can contribute a lot because I'm from aerospace engineering. But honestly, it's not much big difference, the knowledge I impose into the design of the aircraft. Because a mechanical engineer also deal with a lot of things, like here. How to make the aircraft green? We have a lot of way to do it, using a light material. A lot of people talk about composite. We can talk about making a coating is much, the nano coating, to try to reduce the friction between the air and the surface of the aircraft. Or we can use the better engines. And we also have to design the aircraft with a low noise productions. Remember, what's a noise? Noise is also kind of the energy consumptions. Because the noise is energy, you use energy to produce noise. There's a privations. If we can reduce the noise for the aircraft, that means we reduce the energy. Or we can design the aircraft with a lower frictions, lower drags, or using the right types of aircraft to find the right place. Seldom you will see the people use the A380 Airbus, the double-decker, to fly from Hong Kong to India, because there's a short haul. But the Airbus, even you do not have sufficient passengers, is still burning a lot of fuel because the dead weight is too heavy. So how we can select the right type of aircraft to find the right path, that is also very important. So go to here, you will see the composite materials. I'm sure a lot of mechanical engineers now dealing with the composite materials. Even just now talked to the lady here, she also talking about 3D printing. Maybe one day go to the composite. And aircraft already use over 50% of the is a structure already use composite over 50%. And Airbus the same. Look at here. What is the difference by using this composite and the transitional metal? You see transitional metal, we use a lot of fastening systems, rivet, bow, nut, to connect all the structure together. And remember, one bow and nut is very light, but combine the several thousand of bow and nuts, that would be very heavy. That means your aircraft have to carry all these bow and nuts, flying from one place to another. And now for the composite, we all use the glue, just adhere them together. So reduce all this kind of weight. And composite materials is carbon is about 1/4 of the weight of the aluminum. So make the whole structure very light in order to use less fuel. So for the engine, we try to reduce the carbon emissions. Then what else we can do? We try to use a different fuel. Liquid like here, we use liquid nitrogens, liquid oxygens, liquid nitrogen and liquid hydrogens to produce the power to drive the engine forward. But the problem is by using this liquid hydrogen or liquid nitrogens, you need a pressurized tank and make the whole body bigger. Because the weight is reduced, but the volumes to contain all this kind of gas is increased. So this is one of the challenges NASA is now dealing with. And you look at all these diagrams, this is a lot of conceptual design, making by the aircraft producers. Some are using the solar energy to drive the aircraft flying. Some of the engine actually use the electrical motors to drive. And these are new tendencies. All the aircraft engines try to use the electrical driven motor. And the bottom one, you will see there is a morphine structures. Try to design the aircraft like a bird, and in order to reduce the frictions between the air and the aircraft surface. And this is kind of the diagram showing to you about what is the new generation of aircraft. All of these aircraft using the electrical driven motors already. And I'm sure they will come up in the next 5 years, the test. Because Airbus, Boeing, NASA, they all put quite a lot of investment into these areas. So look at the engine more close to us. If you look at the engine like this one, this is what we call the soft tooth. This kind of the engines try to reduce the noise for the engines this noise produced by the exhaust gas at the back of the engine. The reason is where's this kind of noise come from? Because the engine produce the gas is flow very high velocity, but outside the engine there's air is static. So what happens when the air go very fast, very high speed? Then it's called the shear, and this is a kind of the high frequency noise. So this kind of design actually used to mix up the high frequency airflow and the low frequency airflow surrounding the aircraft in order to reduce the final velocity of the air flow from the exhaust from the aircraft engine. So all this kind of design actually is trying to use it to reduce the noise and in turn reduce the fuel use. And of course some material is used to absorb the noise as well inside the engine already. And this picture is very nice. For the lady, she may like it because of the heart produced by the aircraft when it's flying through the clouds. But in reality, in terms of engineers, we don't like it. When you see the turbulence, this is like a heart. But when you see the turbulence produce this kind of patterns of the flow, it means that the aircraft is pulling back. All this is a turbulence. It's an increased friction for the aircraft. So the people is very clever. Then they just put a small winglet here and try to reduce all this kind of turbulence. And this actually is a mechanical engineer can do a lot of job on it. This is based on your basic thermodynamics, and then go to the further is the computer simulations. And from here you will see winglets can solve the problem. The nano clothing can solve the problem. And a lot of mechanical engineers after you graduate or your final year project, basically they are doing in their research on material science or nanomaterials. So all of their outcomes can contribute to the design of the new type of aircraft. So in terms of the environmentally friendly, okay, 4 years ago I was in Morocco, and then I was invited to give a keynote, and then I talked to one of the guys from Airbus. He is quite senior. And then they already started the environmentally friendly scheme, how to ensure the aircraft their waste will not induce any environmental problems. So they have very big Caesar. So after your aircraft to be used for many years, then you are not throwing into deserts. In the past, all the old aircraft were thrown into the deserts. But now they collect the aircraft back. They use the big Caesar to cut off the aircraft, like you cut the paper, and then into small pieces, and then we melt all the aluminum and we use it. So this is the kind of things. There are a lot of aircraft producers and manufacturers. They are implements into the green policies. Of course, some of the materials we select, we also have to consider about not only the end, how to treat those materials at the end, but during the whole production process, would it induce a lot of carbon dioxide or not? So this is also another thing the aircraft manufacturer they are thinking of on that. Flight planning is another thing in aviation industry. They are doing a lot of work. In the past, normally when the descending, we will go to the stepping, then we send descending process. So in this process, it uses a lot of fuel. So now the new design is once it's designed, it's a one go, direct go to the runway. And then in this kind of the descending order, it's reduce the use of a lot of fuel, because the aircraft design is not good for the lower altitude flying, because at the lower altitude flying, there's a lot of oxygens, and then it's burn a lot of fuel and produce a lot of carbon dioxide. Almost to the last pages. Another way we can do, okay, I talked to the chief engineer in Cathay Pacific and Dragon Air. He told me about to be the head of the engineering in their companies. They are not only have to know about the engineering knowledge, they also have to know a lot of things outside the engineering. For example, project management, logistics control, and flight planning, all these kind of things. So this is one thing we have to top up our engineer. Of course, for the fundamental engineers, they have to learn about the basic skill. But when they go to more senior, they have to understand why the flight schedule, the planning is like this. A lot of people will ask, if you want to build a new runway, then your old runway had to go to the saturated level. That means 100% already used. There's no any room to improve it, no any room for the new aircraft to land. I can tell you about if your runway is your airport, the usage already reached to the saturated level, then you got trouble. Because we already talk about disruption control. It's one day the typhoon comes, it's one day there's snoring, serious snoring. You have to block your runway, then get all the aircraft delayed. Then where's the room for those aircraft to go? So normally for the airport, okay, we only accepted the 80% for the saturated level. That's already the most level, because we cannot get it go to 90%. Otherwise, if any accident happens, there's no way to control all the other aircraft to land. And remember, if the aircraft cannot land, they may not have sufficient fuel to go to other areas. Then it will cause another accident. So all this is very important for the people working in the aviation industry. And for the mechanical engineers, basically we have a fundamental, very important core knowledge. And then if we want to jump into this area, it's very easy. In Hong Kong and China, in all the airports and airlines, they recruit a lot of people. Their fundamental background is mechanical engineering, but not others. Because they know that for the mechanical engineer, they can shift to the aviation engineering industry is very easy, because all the knowledge, fundamental knowledge, are the same. So here is my last slide. Okay, the future aviation industry basically is involve a lot of multidisciplinary knowledge. Okay, mechanical engineering, electrical engineering, electronic engineering. Particularly now, there's a lot of aircraft design, what they call the fly-by-wire. That means all computerized, computer control. And the pilot, if he is or she is lazy, they can just press the buttons to control it, to make the aircraft is the autopilot. Then he or she does not need to do anything. Start from the aircraft descent, take off until landing. But most of the pilots, they try to use a manual landing. Otherwise, they really have nothing to do. So this is the end of my presentations. And what I'm trying to do today is give you some very quick overview about this aviation industry and what the engineering can contribute to this new uprising industry in the Asian Pacific region. Thank you very much.